여기 동물 나오겠니?
제일 잘 보여요.
오늘 다 외국인만 다 어디 가셨대?
조금만 좀 더 끓여볼까요?
Okay, time to start. Welcome everybody to today's seminar. Today we have Dr. 대여장비 Shim from Climate Prediction Center, co-led by the NSEP and NWS and NOAA. I will briefly introduce her educational background. She got her BS in meteorology in 1969 in SNU, Seoul. And then she went to the USA to get her master's degree as well as PhD degree. She got a MS in meteorology in 1972 in University of Wisconsin, Madison, and then she moved to the University of Maryland in College Park, Maryland, and then she got a PhD in meteorology in 1981. And then she had worked so many places, but most important career is from 1993 to up to present. She's working in as a research meteorologist in Climate Prediction Center. So, as you may recognize from this latest experience, she has been working on research and development of the method for the extended range forecast for the operational sub-seasonal to seasonal climate prediction in Climate Prediction Center. So she is expert on this climate prediction for over 20 years. Therefore, today we'll have very unique chance to learn about the general and specific things of the climate prediction. And then she's going to talk about North American multimodal ensemble system. So this is a climate prediction and so I would like to ask you to welcome her with this warm applause.
I think that this is a lot. Can you hear me? Is it working?
Hear me better? Yeah. I think this is my about third time I'm visiting to this building, ABCT, and every time I come here, I see so many new faces, which is really refreshing. Where NCPC, we don't have too many new blood coming in, and sometimes they tend to get sort of stay and not much of stimulating discussion coming in among ourselves. Anyway, today I'm going to talk about the North American multimodal ensemble system seasonal climate prediction at NSF. This effort, this is a project we initiated in 2011 after following quite successful multi-models prediction system established at the AECC and the European centers. And the first phase of the NMME was initiated as an experimental system as a part of the climate testbed research project, and that was supported by the NOAA Climate Program Office in 2011. And then it continued on to phase 2 with the actual real-time prediction capability set up in 2012 and continuing. For this year, we are having the NMME expansion project for the high-impact weather prediction pilot projects, partially funded from the special funds after the Hurricane Sandy aftermath. Brief some historical background on the North American multi-model ensemble. Initial planning meetings were held in February and April in 2011 to bring together the participants over mainly the global coupled modeling centers in U.S. And after those two organizational meetings, the first forecast was issued in August 2011. There were only 4 months spin-up period before the first real-time prediction was issued. And we call this phase 1 as the NMME of opportunities, and we are studying feasibilities and whether we can actually do this in operational framework in real time. And phase 2 was the expansion of the phase 1, and based on all the Hindcast data sets made available during the phase 1, that was implemented in phase 2 in operational terms. Some of the specifics of the phase 1, as we requested basically monthly mean forecast data, and the spatial resolution has to be 1 degree and 1 degree resolution. And we only requested for 3 variables: sea surface temperature, 2-meter temperature, and precipitation. But the Hindcast period has to be at least 29 years, to 1982 to 2010. And the forecast length has to be at least 9 months. And also the CPC operational constraint requires that all of these data sets has to be delivered by 5 p.m. On the 8th of each month. And with all these phase 1 period, the Hindcast and real-time forecasts were coming in monthly chunks. And they were, all these data sets we have accumulated as archived and made available to public. And also the forecasts, not only the raw forecast data set, the forecast products were also made available in terms of 1 month monthly mean spatial anomalies and seasonal mean spatial anomalies, and NINO 3.4 index plumes. Also, it goes, the spatial anomalies goes along with the skill maps based on the anomaly correlation from the Hindcast runs. And we initiated experimental probability forecast based on all the ensemble members. And when as phase 1 was in progress, we requested perhaps we should have more, additional variables, including the 200 hectopascal heights temperature, maximum temperature, minimum temperature, and soil moisture and runoff, primarily for hydrological applications. The HindCast data base is archived and complete set of monthly mean for all models and for all initial conditions. And it was made available through IRI at the Columbia University. And these are available for, of course, the real-time forecast calibrations and research activities among the research communities over the U.S. And current NMME system is made of 6 coupled models in the NCEP CFS version 2 and GFDL CM 2.1 and 2 versions of a Canadian coupled model and NCAR CCSM 3 and NASA's GeoSpy. And of course, all 6 of them had HindCast period, at least starting from 82 or some 81 through 2010, and multiple members. CFS having the most number of members per month, 24, and 20 in real-time prediction, and others are mostly 10, and the NCAR has the least number of ensemble members, and with 3. And these forecast data sets we initialize in either multiple times throughout the month or just perturbed ensemble initial conditions at the first of the month. The choice was depending upon the how each providers can accommodate the actual running of HindCast and forecast. And most of the members provide forecast extending out to a year, and CFS and GeoSpy has a relatively shorter forecast length of 9 months. And the model resolution varies from 1 by 1 to maybe 2 by 2.5. And various type of ocean model was coupled to the atmospheric component. And of course, these each providers are continuing with their model development activities, and as they upgrade their system, they'll provide new sets of HindCast and forecast as model system change. And in fact, right now, from this year, there was at least 3 model upgrades being planned. And some of the analysis coming out of these HindCast data sets, this illustrates the comparison, the improvement of the skill levels in forecasting SST in terms of rank probability skill scores over the global ocean based on the HindCast data sets. Top figures illustrates the rank probability scores for NMME. This is, I guess, 6 months lead for the December, January, February season. And bottom is the single models CFS version 2. As you can see, the skills level increased dramatically over the global basin when it's compared to the single model versus multi-model ensembles. And now this compares the CFS version 2 versus multi-model ensemble mean of RMS error and SST over the global tropic strips. Again, the RMS error reduced considerably when we apply the multi-model ensemble. And also the forecast becomes more reliable when we add more member of more number of models, and for both above normal and below normal categories now in terms of the rank probability skill scores. As you can see, the NMME scores lies right along the diagonal compared to the observed relative frequencies. But we still have some problems with the near normal categories. And those 4 panels on the right are the couple of plots coming from individual models. So they are not quite reliable as the probability, forecast probability period increases compared to the NMME skill score. Okay. And this plot illustrates how these NMME multimodal components complement each other. And this is example shows the comparison between the CCSM3 versus NMME. I believe this is the number of ensemble members, or coming from the diversity of the model. So the plots on the left panel, left column, shows the skill increase if we added one more member to a sort of cooler season in the longer lead time period, and or GFDL model at the top. And I think the second is IRI model, which is not current amongst the current member, but it was at the beginning and during the phase 1 period. And one of the Canadian members and CFS version 2 and NASA GEOS at the bottom. And the panels in the middle column illustrates other models input, except perhaps the least amount of increase is showing up in the NASA GEOS model. And then the rightmost panel columns illustrates now seasonal cycle of the SST of linear 3.4 region. Yes, the black is the observed chronological seasonal cycle, and CCSM3 has the cold bias for that, and it just the seasonal cycle just decreases considerably from January through December. Compared to that, the upgraded version CCSM4 captures that seasonal cycle very much so, quite close to the observed. It contributes positively to this multimodal ensemble frame. And this is now a screenshot of our CPC's NMME website. We still has the title, the U.S. National Multimodal Ensemble. We should, it's been almost 2 years since Canadian member joined this endeavor, so we should change that to North American. And these are the list of the products readily available on the website. Seasonal mean spatial anomalies, and monthly mean spatial anomalies, and linear 3.4 plume. And we also have access to another multimodal ensemble system we call the International MME, which consist of the NCEP-CFS version 2 and ECMWF, couple model forecast, and UK Met Office and Météo France. So there's a 4-member multimodal ensemble. And we have a probabilistic forecast, and we also initiated real-time verification. So these products are updated every month. And then we keep that up, all these forecast products in archive. And one of this illustrates the panel of web page showing the monthly mean anomaly predictions, and it's also shown for all lead months, and either spatial coverages, global or North American sectors. And in accompanying that 1 month anomalies is the skill map corresponding to the same lead time and the spatial domain. And so what it's shown here is that 1 month monthly mean forecast showing all individual model predictions, and bottom two are the ensemble mean coming from NMME on the left and IMME on the right. So it showed you that how variable, how models agree or disagree in this month's forecast on where the disagreement is. But for this particular example, NMME prediction agrees very well with IMME, which is somewhat reassuring. And the skill map, this is an example how the skill maps are displayed. Again, all each members and ensemble mean skill map is distributed. And the probability forecast is just basically the dicta size determined from the hindcast variances, and then all individual members were included here. And then it's basically simply counting 1/3, 1/3, and 1/3 of the forecast anomalies. And here's an example of what the ENSO Linear 3.4 plume, the forecast plume looks like. It includes all the individual members of each models, which are in dashed line, and solid line is the ensemble mean of each model. And then the grand mean is shown in the black line. So each month is Linear 3.4 forecast is displayed in this format. And one of the examples of this NMME forecast of it and its application, and this is the drought forecast product. This NMME forecast was used for the drought forecast since I think January 2013. This is an example of the January 2014. And what the panel on the left shows the precipitation forecast for the 2014 and February 2014 in the NMME ensemble mean. And what's shown on the right are the corresponding standardized precipitation index, 3 months I believe this one is, using these NMME precip forecast is shown there. And this SPI forecast provides input to the U.S. seasonal drought outlook, which again shows that the drought in the North California and the northwestern part of the U.S. continues. And this year it's been pretty severe drought in the California, and which seemed to have a breaking up a little bit with the more recent 2 weeks period of rainfall. And then this is an example of the real-time forecast verification. This is each month all the verifiable period maps are displayed in terms of NMME ensemble mean and observed distribution. And for this, I think example is for the January 2014, where the precipitation forecast was fairly good one in this case. basically forecast below normal precipitation over California and over the southern part of the U.S. and the central Great Plains. And Alaskan sector has above normal precipitation, which is very well verified, except the Pacific coast of Canadian sector, where it's above normal precipitation is forecast, while the verification indicate below normal. But the temperature, corresponding temperature forecast wasn't very well verified at all. I think that the forecast was basically above normal over the eastern part of the U.S. while we had a very much below normal temperature over the eastern half in January 2014. So all of these are displayed on the SCPC website and readily available to anyone, all public. And this is now the skills verification for the MMME forecast for the first 2 years of NMME forecast in operation. Year one is started from August 2011, so it goes to the forecast issued in July 2012, and year two from August 2012 through July 2013. And again, this is the old year 12 case mean for the 2-meter temperature on top and precipitation at the bottom. And so the first year cut was relatively easy to predict, and most of members did fairly well in terms of 2-meter temperature. And precipitation skill verification score is very good. And also you can tell which model did perform better than the others, but there's no consistency here. One model does better in one variable, but not so well in the other variable. And the year two period is a relatively hard, difficult period to predict. Most of the model members didn't do so well in both 2-meter temperature and precipitation. And the only, so in this case, the first year winner might have, it doesn't guarantee that it's continued doing well in the second year. So that's why we need multiple members, more than members, in order to compensate, depending on the situation. There's no guarantee that one particular model will outperform every time. So for the phase two, now we're getting into more of a sub-seasonal aspect, and we're requesting the high-frequency data sets for at least 45-day forecast period, and in order to support the North American hydrological prediction for drought and extreme events. And we chose about 45 variables, surface fluxes and other circulation variables and multi-level, and also ocean and sea ice. This phase two data set is going to be hosted at the ENCA, and ENCA will be the data distributor. And all HiCast data set is supposed to become available by August 2014. And one of the sub-projects of this sub-seasonal forecast protocol is the focused on MJO, and there's a score for multiple initial conditions in the month of November, and going up, I think for 45 days we forecast data sets. And it's not required to provide all 45 variables, but just limited variables given for the MJO diagnostics. And so these NMME spawn out these other sub-projects and sub-diagnostics projects in addition to the supplying the real-time forecast, operational forecast effort. And so in near-term plans for NMME, we'll try to sustain and improve the seasonal forecast system, and there will be shortly documents coming up, the operational NMME and 5-year plans and so on. And the continuous new models and upgraded models will be incorporated. And there's a plan for community effort to analyze the phase 2 hindcast data sets. And for the, we plan to develop the seasonal forecast capabilities in order to link the WMO sub-seasonal to seasonal projects. And perhaps that there is a plan, we'll be able to have a community-wide workshop maybe in 2015 for planning the next phase of NMME. So that's, and all these NMME data were both phase 1 and phase 2 hindcast and the real-time prediction data sets are available. And the top website address is the real-time forecast address. And second, middle one is phase 1 hindcast website, and phase 2 will be the reforecast data set will be available from that. So that's where the NMME project at NSEM stands, and I'll stop here and answer any questions you have.
Okay, thank you for very interesting talk. So, any comments or questions from the audience? Just don't hesitate to raise your hand. It's a very unique chance to learn more about the different time prediction systems. I would like to.
Yes.
My question is that I noticed that several models are participating in the sub-seasonal prediction activity, and then I saw that
They're the,
yes.
those are the,
So these models include both tier 1 and tier 2 systems, or just tier 1 systems?
Let's see, the EMC global ensemble forecast system is tier the atmospheric only, and the other 3 are coupled tier 1.
Then it's basically in terms of this sub-seasonal forecast, maybe we don't need to worry about the tier 2 system participating in this activity.
Well, most of the system we have are the fully coupled tier 1. Tier 2 system, I don't think anybody actually volunteered with the tier 2 system. NSEP global ensemble forecast system is currently going out only to 18 days, but they are planning on having some hindcast experiment extending out to about 45 days. I think that's what they are including in this effort.
Based on your experience, what is your recommendation to include both tier 1 and tier 2, or just
exclude tier 2 and use only tier 1 if we have enough number of systems.
System, yes, I think so. Even though 45 days might not be quite long enough to have a full impact of the SST variability, and yet our experience is that there is still the coupled system does perform better in that time frame, especially the MJO aspect. And unlike APCC, our approach is that NMME, all the data, we cannot handle and work as a data distributor. So we rely on other institutions for the data delivery, and we focus our effort on the creation product.
So in your phase 2, the design looks like heavy, maybe, very heavy, tough job for who runs the model and who has to deliver all the data.
Right.
But although the CPC is operational center, so you have some people who does operation, but the other research center may not have people whose mandate is to run the operational schedule.
Right. They sort of committed themselves doing it in the operational setting. Yeah, that's one of the conditions we impose from the beginning. They have to deliver these data sets on real-time basis. And at some point, there was a talk about actually operationalizing this real-time prediction part by bringing all these models into the NCEP operational product suite. But that requires tremendous amount of computing resource, and at the current computing level available at the NCEP, we cannot do that. But fortunately, each institution agreed to make that effort, and so far they have been delivered on time, all this real-time prediction data.
And is the multimodal ensemble is the sort of the national strategy to deal with this the climate prediction, that because you have many centers who develop their own model, and then maybe it looks like not the scientific decision, but
well, it's in a way we always wanted to have these research institutions involved in developing the real-time capability and helping the operational centers. And I think the economic situation basically forced, especially GFDL and NCAR, to work with operational centers and prioritize their effort towards helping the actual real-time operations. Because when these research centers, they have to apply for the research grant, and their paycheck basically comes from their funding, whether for their proposals funded or not. And more of the funding agencies put that aspect as a priority. It's not just the simple basic research is important, but if it doesn't help the operations and real-time prediction, that's getting the lesser of the priority over those projects which try to help the research to operation transition.
And about the variable, in phase 1 you have included added some additional variable for the hydrology application. And then in phase 2, you include many variables.
Yes.
I have two questions regarding this variable. Is there any real application of the NLME result in hydrologic study?
Yes, so as you can see, our drought outlook products utilize the NMME precip and temperature prediction to compute the SPI and other drought-related indices, and that's going into the drought outlook. And another aspect is the tropical storm activities, and that's part of the expanded variable list they're considering. When we were selecting the variables, that was part of the consideration. Eric Wood at the Princeton University used heavily the NMME data set for the hydrology prediction with their SAG, I think. Big density, the University of Washington, the big model, which is hydrology model, also uses the NMME product.
So in the member who deal with the decision of which variable we should collect and in which time scale, are there only meteorologists or other people?
No, there are the CTV under the Climate Program Office funded projects. All the investigators which was funded under the CTV project were part of the committees who sort of made a decision on the variables. That includes Dennis Lettermeyer, for instance, and Eric Wood, who are hydrologists. And depending on other agricultural sector, for instance, I don't know whether any of the Department of Agriculture people are actually getting into this, interested in this, but they've been sort of using our products heavily in Agriculture Department for crop yield prediction and so on. So I'm sure they will be interested in coming in.
So I think that first the resolution of the MME is relatively coarse than CFS was to apply the result to some application standard. So do you have any some plan or some consideration?
Well, our CFS version 3 is going to current sort of candidate is T382. And GFDL's flow model is 50 kilometer resolution, which will be starting in May, I think. And so all of these member coupled model system are getting into the resolution upgrade also.
According to your lead time, you have lead time from the 0 months to the 9 months. Some actually are not very favorable for having this extended 3 months to the 9 months. So do you think we do have any benefit from the extended lead time?
In some cases, where they will have long-term planning, for instance, energy sector, while they would like to have as long as possible. And so that's the reason why CPC seasonal prediction goes out over a year. We're going 13 months. I mean, 13 seasons, but overlapping seasons, so in practice it's going out to 13 months.
So perhaps to decide the lead time, and maybe we need to think about the application
Application
sector where they
sectors,
really
yes.
want this long real forecast.
But the predictions will be very low. I mean,
It is, they understand that,
Okay.
but it's better than nothing. That's their point of view. Yeah, that's why we always provide with skill maps, skill masks. We tell them that's the kind of skill level you would expect. They understand it. Any others?
Did you mention your data used in the hydrology part? My question is that how did you discuss or talk with the application scientists?
Well, we include those sectors who are actually using the climate predictions. And nowadays, the primary sort of customers for long-range prediction is the agricultural sector and energy sector. But as some of these economic activities develop and they are making long-range planning, there might be some other sectors who might be coming into looking for long-term climate protection. So our primary customers are basically agricultural sectors.
But the operational, the official CPC climate outlook is man-made, isn't it?
It's mandated.
Man-made. I mean,
Oh,
forecaster.
of course, the input of the actual forecasters, yeah. Yeah, well, all these are the maps and all this analysis of the NMME results are provided to the forecasters every month. And they look at every one of them. And then there's always forecast insight, which is added in our final output. And they did a test on, not in the seasonal part, but extended range forecast, or day 6 to 10 and week 2 predictions. And they actually automated the system. And they scored with the final forecast, which also includes the forecaster's input. So far, it is the forecaster input is not negligible. It is still better than automated products. So that's how we keep our jobs.
I have one very practical question. As far as I know, CPC is kind of operational center, and who is also in charge of issuing seasonal predictions. Suppose that, unfortunately, CPC was wrong in terms of predicting next season time prediction. Then people outside will blame the CPC, and then who is going to responsible for?
No, we tell them these are the probabilistic predictions. We always tell them there's a chance that this. That's why our confidence level is included in the outlook. If it's maybe it's just a 30% probability of above normal, then we are not that confident about that happening compared to the 40%, for instance, 35 or 40% chance of being above normal in that area. And people understand that. Our forecast product users understand that. That's our always sort of, we are struggling with how we explain to the general public this probabilistic nature of this seasonal and climate prediction. And at least in U.S., in general, they do understand that it's not perfect deterministic prediction we are providing. And of course, if you're wrong, you try to attribute what factors influence the outcome of the season and why our prediction was not quite correct. But sometimes it's very difficult to attribute what vectors.
Okay, if there is no further questions, then we're going to stop here, and then thank you.